All right, it's day 6 of our distance learning, and we are going to talk about electromagnetics. So before we do that, today we have an interactive notebook about electromagnetism, and electromagnetic waves part 2 investigation is due, as well as your quizzes, EM spectrum quizzes is due today. Now on Tuesday and Thursday you have station labs for the week, part 1 and part 2. Part 1, so I broke it up your station lab into 2 just to make it manageable for you. On Wednesday, interactive notebook, which you'll do after the live session, will be due on Wednesday. Now, we don't have any ed puzzle and also quizzes for the week about electromagnets. However, on Friday, I will be launching your project that is due at the end of the month. Okay, so that's us, and today we're going to talk about electric and magnetic forces. So before we start with that, let's take a look at this video of the uses of electromagnets.
And that's coming up after this.
96.3.
As a radio DJ, I'm surrounded by permanent magnets all the time. Like this one here, found in my headphones. And these, found in the big speakers. And there's even one in this microphone.
And would you believe there's a link between cows and magnets, as our vet explains?
The cow magnet will sit in the front stomach of the cow, where it can attract hazardous pieces of metal, like this bit here, which the cow may eat by mistake. While this piece of metal can roam free in the cow's stomach, it could puncture the stomach wall and cause the cow a lot of harm. But while it remains attached to the magnet, it can cause no harm at all.
Permanent magnets are useful, but sometimes you need a magnet that can be controlled. A magnet that can be switched on and off, like the one at the scrapyard. It helps them move bits of metal from one place to another. Doctors use temporary magnets too.
As an eye surgeon, sometimes we have to remove tiny bits of metal which become embedded in the backs of people's eyes. And if you look at this X-ray, you can see this tiny little fragment here, at the back of this person's eye. And this could cause serious damage. And we remove those fragments using an electromagnet like this one. Now here we see with the electromagnet off, it's not able to lift up a bit of metal like this paperclip. But if I turn the magnet on, we're able to lift up that paperclip. And that's how, as an eye surgeon, we use electromagnets to remove bits of metal from the eye.
Magnetism gets everywhere. There's a magnet in anything that has a motor, like your hairdryer or the microwave. There's a magnet in your telephone, in a computer, in a video recorder, and your TV.
All right. So, while you're watching, I ask you to type or write down the name of some uses of electromagnets. Go ahead and put that in your chat box or in your notebook. And according to some of you, it says speakers at the doctor's office and also hair dryers. So these are some everyday use of electromagnets, and we're going to discuss that today. So our goal for today is for us to define what are those forces of nature that creates electromagnetism. And of course, we wanted to determine what factors determines the strength of electric and magnetic forces. We'll start first with this base knowledge that we have known before about atoms. We know that atoms can be a positive or negative charge, and protons are positive charge and electrons are negative charge. Now, if the numbers of protons and electrons are equal, then an atom is neutral. But atoms normally and also have the tendency to gain or lose electrons easily. And if that happens, electrons that are gained by the atom causes the atom to be negative, and atoms that tend to lose electrons becomes positively charged. Now, metals are normally positive charged, just like your ions, and when these charged atoms encounter another ion that is of a negative charge, then they attract and bond, and that's what we are going to make sense of today, which is the electric and magnetic forces and create the forces of nature. So, magnetic forces are the forces that could be attractive or repulsive between two poles. Again, magnetic forces are the forces that has attractive and repulsive forces between two poles. So if you look at the diagram here, you have two bar magnets, and one has a north and south pole, and therefore two opposite forces, north and south pole, attracts, but if you have two same poles, they repel. Another force of nature is called your electric forces, and they happen when ions create attractive or repulsive forces. And we can observe that in chemical reactions in chemistry. Now, these two forces can work independently or together. And we're going to look at how these two forces are working together that creates what we call electromagnetism. It is a force combining both electric and magnetic forces. But before we take a look at the combination of the two, let's take a look at both of these forces separately. So, magnetic forces. All matters are made of atoms, and we know that. And there are negatively charged electrons around your nucleus of the atom that moves a certain direction. Now, when these electrons spins in the same direction, if you notice in this diagram, there are three electrons moving in different directions. But when magnetism happens, these electrons will move in the same direction, creating that invisible force known as magnetism. Now, the power of a magnet is known as the magnetic force of the magnet. Now, this short video will show you how magnetic forces or magnetic field happens. We can't see magnetism unless we represent it in this demo. So magnets have two poles, north and south. So in this case, we have a bar magnet. As poles come close to each other, they either attract or repel. Now, around the poles is an area known as the magnetic field. So we'll take a look at that. The farther from the poles, the weaker the field. Also, the stronger the magnet, the larger is the field. So let's take a look at this demo. Now, as you can see, it creates this field as what you can see. And the ion filings are arranging themselves in a certain way, showing how the attraction is happening and creating this magnetic field. Now, we also saw that in the magnets that we have at home. And when there's attraction, of course, there's movement, and that is another way we take a look at a magnetic force happening in the magnet. Now, let's take a look at the other force, which is your electric force. Now, electric charges create electric force. So, like the magnets, there are two different charges, positive and negative charge. And they either attract or repel. Now, a very good example that I'm sure you guys have experienced is your static electricity. When you walk across the room and get a shock when you hold the doorknob, that is a static electricity. Same is true with this diagram or picture right here. When you rub the balloon in your hair actually gets attracted to the balloon and causing this static electricity. Static because the electricity does not move through a current. It just stays that way and stay in one position, causing that electric forces to happen. Now, my challenge to you is to create an electric charge at home. You can also use a wool socks to create static electricity. Hold it in your head and see what happens if that object causes your hair to stick up, and demonstrate that electric forces that you generate. Now, another type of electric force is your current electricity or electric current. Now, electric current is a rate of flow of charged particles. Now, electric charge we said that there's positive and negative charge. When electrons flow in a circuit, current is produced. And we'll take a look at that. Normally, your current is measured in amperes. So this is an ammeter. It measures the current in a circuit. So how does an electric current work? We have to have a battery or an energy source that gives energy to electrons and pushes them out around the current from negative to positive terminal. And as that current flows, it powers your device, or let's say a light, in order for that current to keep flowing, powering your device. Now, when electric force is generated, of course, it generates electric field. Now, the area around the electric charge that experiences the force exerted by the electric charge, that is the electric field. Again, an electric field is the area around an electric charge that experiences the forces exerted by the electric charge. Now, looking at the diagram here, so that's a direction of your electric field. So the direction is outward. Now, the farther from the charge, the weaker the field. And the greater the charge, the greater the field. So, what's the difference between static and current electricity? So, write that down in your notebook and let's compare notes and type it on the chat box what you think is the difference between the two. Now, if we combine electric and magnetic forces, we create what you call electromagnetism. Now, electromagnetism is when the electric charge moves and create magnetic fields. So an electric current is moving a charge, and as that charge is moving, okay, that magnetic field is actually generated, and that's how your electromagnets are produced. So how are we going to create electromagnetism? So this is how you can set up your electromagnetism. So first, you have to wrap a wire around a piece of iron or steel to make the magnet stronger. So in this case, I have a sample right here wherein you wrap a wire around a piece of magnet, and the more loops you make, the stronger your electromagnet is going to be. Now, there are some examples of electromagnet models that you can use in your project. These are some examples of how you can use your project. But this one, I have a sample of the electromagnet that I made, which is the motor right here. So let's take a look at this one. So you just need the magnet. So let's take a look at this sample. All right. So let me show you some uses of electromagnetism. So unlike permanent magnet, your electromagnet can be turned on or off depending on the amount of electric current that flows through it. And some uses are hard drives, speakers, motors, generators, MRI machines, and scrapyard magnets that pick up heavy metals to separate the metals from everything else. So these are the uses of electromagnets. And you are going to build that electromagnet or make your electric motor because it runs through electromagnetism. Now, just a summary. So what two things could this person do to increase the electromagnet? First, you increase the loop or increase the current or your power source or the voltage. So just to summarize our lesson today, that we identified and explained the forces of nature that create electromagnetism and determine what factors affect the strength of electric and magnetic forces by using data. So, and that's what's going to happen when you do your experiment. So this week, station labs will be posted Tuesday and Thursday. So the first part of your station lab will be watch it, read it, and research it. Watch it, Bill Nye, there's questions. Read it is about electromagnetism and energy transformation. What happens when an electromagnet is made, what energy transformation occurs, and also research it, how electricity converts metal to be magnetic. Now, part 2, which is due on the 18th, and I'll post that on Thursday, is illustrated. You're going to draw a bar magnet interaction and transformation of metal to become electromagnets. You're going to draw that. And also for the write it, you're going to summarize what you learned about electric and magnetic forces. For the assess it, it's a short quiz that tests one's knowledge in electromagnets. And for organize it, it's true or false statements about electromagnets. Here's your challenge. You're going to build an electric motor, and I'm going to show you the demo that I have here with me that I did last night. Here's my electric motor all ready to go, and let's see if it's going to work. There we go. So it depends on where you place the magnet. So it's going to roll. There we go. Now if you notice, if I let go, if the copper wire that's not exposed is not in contact with the safety pin, it's not going to move. There you have it. The challenge is for you to be able to try it yourself, and you have until the 29th to finish. There you go, like that. See, almost so powerful. There you go. Fresh battery, so that's why it's really fast. Okay, so this is a nail and it's non-magnetic. Okay, so if you notice, it doesn't, they won't stick, right? So it'll become electromagnetic once an electric current passes through this nail by having a circuit. So connect battery, wires, and then the coiled. So these two things that used to be not, this is magnetic. There you go. So now it depends on the coil or the loop of how many loops you have for the magnet to be stronger, for the electromagnet to be stronger. There you have it, electromagnet. All right. So here's another example of the electric motor model that you guys will use. Here's another example of an electric motor that is of a different setup. Let's take a look. All right, pretty cool, right? So you can also use this and you can also create your own and replicate. Try to research more examples of a DIY electric motor experiment. And that's what you guys will do starting Friday. So I will be posting information on how you can work through your project to make your electric motor model. Now, let's say for example, you have no materials that is working whatsoever. Just make a model and make your own model. Any type of model that I showed you or whatever you found online that you can replicate, do so. This copper wire right here can be bought in Walmart or Michael's craft store. I don't know if it's open or not, but Walmart definitely in the craft section. You also need a strong magnet. You need strong magnet, which is a neodymium magnet, strong magnet. You can buy that in Amazon too. It can be this big or a smaller version, just like the ones you saw in the video. And of course, your battery. So you can use a big battery or just a small battery that I have here. And you also need safety pins. You can use safety pins or paper clip just to where you can hang your electric motor. So this is our setup for our experiment. that you are going to try and do at home. Okay, there's no more questions. You guys are free to go, and I'll see you next week. Bye.